Now, in our lab, we just review some morphology about congestion or thrombus and infarction in this lab. Okay, let's begin. Sure. We need to know some morphology of congestion, thrombus, and infarct, the different type of infarct, and to understand the morphology of hemorrhage. I remember I told you some the dimmer and the hemorrhage is studied yourself. Yeah, you just study by yourself, and it's very easy to understand. Okay. And also, when the growth specimen and tissue sections today, you can see some hyperemia, and also the hyperemia, meningitis, and some maybe the congestion, the different organs, liver, lungs, and several hemorrhage organs, the brain and the lung, pleura, yeah, subpleural hemorrhage, and the kidney, and several thrombus, vein, artery, heart, valve. Yeah, you can see the different portion. So maybe in the vein or artery or the heart chamber. So maybe on mitral valve. And then is infarct, pale or white infarct, and hemorrhagic infarct. Say the red infarct, a different organ, spleen, kidney, lungs, intestine. Talk about the tissue section. We just say some about congestion and one thrombus. It's a mixed thrombus. We just know the lamination about the platelet and the fibrin. Some may be red color. It's red blood cells. And in fact, say the pure infarct and hemorrhagic infarct, some edema and hemorrhage. It's very easy. Yeah, we just show some pictures or maybe some digital slides. Okay, the first growth specimen is appendix. You know, our appendix is more often to have some inflammation, especially we'll say the acute appendicitis. Sure. If this appendix have inflammation, you can see the hyperemia about the blood vessels. We say the blood vessel, yeah. On the surface of the cells, you can see the blood vessels, hyperemia. This hyperemia is just because of the inflammation. We have studied the hyperemia may be in normal active of our skeletal muscles, or maybe in some abnormal, just like the inflammation, also can give a dilation of the blood vessels. The next one is meningitis. This is the baby's brain. We also can see the blood vessels hyperemia. Yeah, it's a fixed specimen, so the color may be changed. It has fixed use formalin maybe for a long period. So the color may be black, but you know in the fresh specimen, it should be red or black red color. It's blood vessels. The many blood vessels hyperemia. And do you know the meningitis? Yeah. You know, sometimes a baby maybe have a infection of the bacteria. Meningococcus. Yeah. I think you maybe studied in the microbiology. The meningococcus, this bacteria can infect it and it cause a meningitis. You know, this epidemic cerebrospinal meningitis. Yeah. Sure, it's also a hyperemia because of inflammation. This one is cerebral hemorrhage. Okay, you can see here maybe we have a video. Yeah, have this videos here. Okay, suppurative meningitis. You can see this baby is 10 months. Yeah, it's Chinese 10 months. Suppurative meningitis. Also, many blood vessels hyperemia. Yeah, the red arrow. Okay, it's also hyperemia. Many blood vessels. Okay. Next one, hemorrhage. You know, the hemorrhage, say in cerebral hemorrhage, especially in the hypertension disease, those some old people maybe have this hypertension, and this patient have a large mass in the lateral ventricle. This is the lateral ventricle, but if the bleeding entered in the lateral ventricle, we can see a large mass. It's a blood clot. Yeah. So here also a video. Yeah, there's also a brain hemorrhage. You can see this one. Yeah, this black mass is all the bleeding from a clot in the lateral ventricle, and the primary area. This is the primary bleeding area, but it's ruptured into the lateral ventricle and formed a large mass. Okay. Next one is very small hemorrhage. We have studied the pedicure. Yeah, very small hemorrhage point, and maybe 1 to 2 millimeter in diameter. So you can say this baby is pleural. It's subpleural hemorrhage. Many small point. It's pedicure. Yeah, very small, but no hemorrhage point on the pleural. Here we also can see a baby's lungs. Okay, here this is a high power. You can see this point. This red color point is pedicure. Yeah, a small hemorrhage. Can you find the normal baby's lungs? It's very clean. I have studied some dust or dirty deposit in adult lungs, but in the baby lungs, it may be very clean. Yeah, no dust or dirty deposit, but sure, these babies have hemorrhage. Okay. Next one is kidney. It's also very easy. I can say many hemorrhage point. Yeah, it's red point. It's hemorrhage, renal hemorrhage. Some disease or maybe toxin can cause the renal hemorrhage. Some toxin or maybe drugs entered the glomerulars, can cause capillary rupture and cause the bleeding. So it's renal hemorrhage. Here it's a boy, yeah, 8 years old. And the boy see many red points in the medulla and the context. We also can see many red points, also hemorrhage. Okay, here is thrombus. At two veins, this is the thrombus. It's just like a worm. Because these thrombus have detached from the vein wall, so we use a line attached here. So it's a thrombus. And this one and this one is large thrombus. And though it's just like a large cast in the vein lumen, we have studied the DVT. Yeah, it's thrombus is just a DVT, deep vein thrombosis or deep vein thrombus, a very large cast. Here is the thrombus in vein. Okay, also can see the videos here. Yeah. Okay, can see the red arrow. 1, 2, 2 thrombus in the veins. Here we have studied most of the emblems, the primary emblems come from the DVT. So if this large cast detached from the veins maybe entered the primary circulation and that can cause the embolism, the primary embolism. This thrombus is artery. Here is aorta. This is aorta, and you can see this aorta is abnormal. We studied as a sclerosis, yeah, as a sclerosis plaque, but now we can say it's not smooth. Tumor is not smooth, and maybe have some plaque as a sclerotic plaque in aorta, and here, say the thrombus, also thrombus in aorta. We also have these videos. Yeah, and another aorta is another patient aorta. Here, thrombus. Yeah, it's a large thrombus and the red colors. This is the aorta. Okay, if the thrombus is in heart chamber, here it has a large mass. You see the mural thrombus. Do you remember this term? Mural thrombus. This is left atrium and the left ventricle. This is the left ventricle and left atrium, but here we see a large mass. It's mural thrombus. Sure. You know, if this is mural thrombus very large and detached from the atrium, we can cause the occlusion of the mitral valve orifice or maybe entered the aorta, cause the embolism, the different organs. It's also vegetation. Yeah, it's also thrombus, but the vegetation, it means thrombus, the valve. Here is the mitral valve. So this is the mitral valve. The fiber cord is very thin, but on the cusp, you can see very small thrombus. It may be composed by platelet and fibrin. Sure, this patient is rheumatic endocarditis. Okay, have this vegetation here. Okay, it's heart. Okay, you can see the mitral valve, very thin And this is the fibers called papillary muscle, and this one, yeah, the high power can see very small point. It's pale or white point just on the mitral valve cusps. It's vegetation. It's also a rheumatic endocarditis. So this is a China word, China character. Maybe you cannot recognize this one, but it means rheumatic endocarditis. Okay, this is also thrombus. So we have studied the different types of the thrombus. Now, in fact, the pale or white anemic infarct. This is a white or pale area. The necrosis area is white or pale color. It's a spleen. It's a large spleen. Maybe have the chronic congestion. Yeah, this area. The infarct area. I remember we have studied the necrosis, coagulating necrosis about the spleen or kidney. Sure. If this necrosis is just because obstruction of splenic artery, you can say it's a infarct, yeah, pale or white infarct. Okay, it's also spleen. Here, oh, pale or white area, it's a infarct. It's normal, and this area is abnormal. Sure. When the fresh infarct area, we also can see the border is very clear. Here is a border, and some hyperemia or congestion, and maybe bleeding, inflammatory cells in this area. So it must use microscopy. We can see the inflammatory cells and maybe bleeding, congestion. But use our naked eye, we just see the border is very clear. Yeah, normal infarct area and border. Okay. Next one is hemorrhagic infarct. It means many blood cells in infarcted area or in the necrosis area. So the lungs or intestine, you can see some necrosis area will have blood red cells. Here, it's a segment of intestine. I remember we have studied this semester. And last lab, we studied the necrosis, and here is a segment of intestine, and the color is black. Black colors is sometimes maybe the bacterial infection combined. The infection of bacteria can cause the gangrene, the wet gangrene of intestine. Sure. The first is ischemia, and then necrosis, and then bacterial infection. So it's 3 steps. First, maybe occlusion of the artery, and then necrosis, and then infection. Here. Okay, also have this video. Yeah, it's also a segment of intestine. Hemorrhagic infarct, the black color, or maybe red colors. Today is about hernia. Yeah, if this is the intestinal hernia, and this segment of intestine have a teaching in the area in the cavity. So first is congestion, and then the blood flow in arteries will be slow and stop can cause ischemia and necrosis. Okay, then I can see the liver congestion. This is not liver. Do you remember the term nutmeg liver? Nutmeg, yeah. It's a touch surface of nutmeg. So this is a chronic congestion of the liver. This area is most like a nutmeg cut surface. Chronic congestion. Okay, the same specimen. Yeah. In microscope, below the chronic congestion, can see the different areas in the lobule. This is central vein. Yeah. This empty domain is central vein, and around central vein, you see many blood cells. This is the digestion area. The sinusoid dilation and many blood cells in the sinus. And the second character also can say this one. Yeah. Fatty change. This is fatty change. Sometimes the side have acceleration. It's fatty change. So even names with our naked eye, say red and yellow color. The red color is congestion area, and the yellow color is the fatty change of the whole side. Okay, and say the mixed thrombus. Mixed thrombus means the elimination of fibrin and platelet and some blood cells which layers. So the gross specimen is also veins. It's thrombus in veins, but also can say the lines of sand. To remember the lines of sand. Yeah. With our naked eye, we just say the pale or white lines, and then maybe black or red black color is line of sand. Give us a lamination appearance. With microscopy, also can see the platelet and the fibrin lines, and this area is many blood cells. So it's also a line of sand. Fibrin and platelet and blood cells. Also platelet, fibrin, platelet. This is blood cells. Okay, however, the yellow arrow is blood cells and many leukocytes in this area. Also, sometimes this is a repair of leukocytes, different types of leukocytes. And this area, the blue arrow, it's platelet and fibrin. So color maybe pink area. Also, blood cells and the leukocytes. So it's the line of sand. The clinic, we studied the pictures last time. So the clinic also can necrosis tissues is white or pale. In fact, this area and this area also in fact. Last time we given it is necrosis. Yeah. But today they say it's they make or pure or white in fact. This is necrosis area and different cells around the border. Okay, however, also can see the glomerulus and the many tubing around the glomerulus, but no nuclear in this area. So it's necrosis. But this necrosis is just because of obstruction of the renal artery, or maybe a small branch of the renal artery. Okay, it's the same as here and here. White, or maybe yellow-white area is the necrosis tissue. And this kidney have a multiple necrosis, so this area also the necrosis. Okay, then we studied some morphology about lungs. So I like to review some normal structure of lungs. First, see our normal lungs structure. No, larynx, trachea, and the bronchial tree. Yeah, the different bronchial tree. It's the left primary bronchus, and this one is secondary bronchus, and the third smaller and smaller. This is a small bronchi. It's a normal structure of our lungs. Here, in histology, in normal histology, we can see the bronchial walls, especially the epithelium. You know, when you to diagnose this in lungs, the first step, you know, we must to recognize its lungs and not the other organs. Yeah. So, how to recognize the lungs? If you recognize the epithelium, this is epithelium. Do you remember the epithelium? Pseudo-stratified, yeah, pseudo-stratified columnar epithelium. This is a pseudo-stratified columnar epithelium. And then you can say this is also a character, cartilage. Yeah, you know, in our bronchus the trachea have a C-shape cartilage. This is also a cartilage. This is around the bronchial. Sometimes when we can see the lung tissues, the alveolar and the septum. This is vessel and the nerve. Yeah. The high power is very clear. Yeah, the epithelium is very clear. Pseudo-stratified and the many ciliars. Yeah, this is the ciliated columnar epithelium. So the cilia is very clear. So we can recognize this epithelium. You can recognize the lungs or bronchus or bronchial wall. This is a different cut section of smooth muscle cells. This smooth muscle cells. And here is gland, serous gland. In the submucosa, let's say this gland, yeah, lamina propria. This here is the lamina propria. This is many gland. Some may be the serous, or some may be mucin. Yeah, mucinous gland. It's also cartilage. It's normal structure, but we must know along the bronchus trees, the diameter may be smaller and smaller. There is a progression of pseudo-stratified columnar epithelium. It says change in the lunge, in the large bronchus or large airways is stratified columnar epithelia, and then change in the small bronchus. Bronchioles, you can say the epithelium maybe have change. Yeah, maybe cubital and less ciliar on the surface. And the last, we can say in alveolus, no cilia. It becomes a type 1 or maybe type 2 alveolar cells. Yeah, it have a change shape epithelium. Sure, the gland. This is a gland and maybe serous or maybe mucinous gland, but it also have a change. The gland maybe less and less here disappeared. It's just the septum of the alveolar. So in the septum, or we just say more capillaries. Yeah, to exchange. Yeah, the gas exchange. We need more capillaries in the septum. No gland. Smooth muscle cells, it also have a change. The smooth muscle cells in this large bronchus also can see the smooth muscle cells and the small bronchus, especially the terminal bronchioles. We can see a cycle, yeah, maybe 2 or 3 layers. The smooth muscle cells can form a cycle around the wall, and some elastic tissues also in the wall. The cartilage, you know, it also have a change. The cartilage is its character in the trachea and the large bronchus, but in the small bronchus, it's maybe a piece of the cartilage, small and then disappear. Okay, it's a normal structure of our bronchus and the lungs, and then to the alveolar. Here, this is just a figure about the terminal bronchioles, known as the bronchiolar and very small diameter. So if our bronchial trace to the bronchiolar, and maybe the diameter is 1 to 2 millimeter. Yeah, the diameter very small. Here, the terminal bronchiolar, and then the next step, the next is respiratory bronchiolar. It's also very small. Can you hear me? Sorry?
Yes, sure.
Okay, okay.
Yes,
Yeah, okay, thank you.
sure.
Okay, we continue. Okay, here is the respiratory bronchiolar. It's very small, the terminal and then respiratory. And then you can say alveolar duct. Yeah, alveolar duct is here as well. And then many alveolar. Sure, this is alveolar duct. We have several alveolar sac. Do you remember alveolar sac? It means several alveolar can combine a sac. It means alveolar sac. So it's a step by step, and the terminal tissue is alveolar. Okay, it's a branch of the veins and the capillary beds combine the gas exchange. Yeah. Here, in microscopy, sure, sometimes we must recognize a different branch. Maybe it's difficult, but if you look at many sections about lungs, you can recognize it very easy. Here, it's a respiratory bronchiolar. This is the alveolar sac and alveolar duct. Yeah, you can see this area, this red or pink area, especially in the alveolar duct. You can see some just like a nodule. Yeah, this is the enlargement nodules, but this is the smooth muscle cells, the different cut section. Around ours, a small bronchiole is respiratory bronchioles and have a small muscle cells around the walls. So on the cut surface, we can see some just like a noodle at smooth muscle cells, the cut section. And then many alveolar. The alveolar is very easy to recognize, but the alveolar duct and several alveolars combine a sac, and here is respiratory bronchiolar. This one and this one may be difficult to recognize. Okay, the terminal tissue is alveolar wall. You can see the alveolar. Yeah. This is the capillary erythrocyte. Yeah. The capillaries, and this is our respiratory membrane. Combined respiratory membrane. You can see it's composed by alveolar, epithelium, and this is alveolar, yeah, the type 1 cells, and have a basement membrane, and here is the capillary basement membrane, and this is erythrocyte, the capillary endothelium, yeah, this is the capillary endothelium cells. So our gas change, the oxygen entered the capillary, and carbon dioxide outer. So it's a during of a gas exchange. It's a normal function of our lungs. Okay, in microscope is a high power. Sometimes it's very difficult to recognize the different types 1 or types 2 cells, but you can see it's empty alveolar. Yeah, also alveolar. This one is type 2 cells. Maybe a large nuclear and many cytoplasm. Yeah, type 1. And this one is this is type 2, and this one is type 1. Yeah, type 1 cells. Here is capillaries, erythrocyte, and this one is macrophage in the alveolar cavity. The macrophage may be eat more and more dust or dirties. Sometimes we give its macrophage a name, just like dust macrophage or dust cells. Yeah. Also the type 2 and type 1. Type 1. Okay. Then we studied abnormal about our lungs. First, congestion. These lungs, you can see the lobes have a different color. Some area maybe have a brown or maybe brown red color. It's a congestion area. So if just use our naked eye, sometimes we cannot diagnose it's chronic congestion or hemorrhage, or maybe some have hemorrhagic infarct. So we must use microscopy. If you use microscopy, you can see the chronic congestion, the capillary congestion, many blood red cells in the capillary, and the character of the chronic congestion we have studied is heart failure cells. Yeah, to remember, heart failure cells. The erythrocyte is phagocytized by the macrophage, can form the hemosiderin deposit in cytoplasm. We say heart failure cells. In this alveolar cavity, you can see many heart failure cells. The brown color is hemosiderin. Yeah. So if you look at this picture, it's just a cut surface of a chronic congestion. Maybe you cannot give a correct diagnosis. But if you give this microscopic pictures, you can see the capillaries congestion and many heart failure cells in alveolar cavities. Okay, you give a right diagnosis. It's congestion. Here, it's also a red color or brown color on the color surface of lungs. But using microscopy, we say this area is different or abnormal area. Here is the alveolus. Yeah, this is alveolus, but this area is abnormal. More and more blood red cells in this area. This is the emphysema. It's empty. It's emphysema. Means many areas in the alveolar or in these necrosis tissues are called the emphysema. But this red color is more and more blood red cells. Sure. If you give a diagnosis, it's infarct, hemorrhagic infarct. It means necrosis. You must find the clues to diagnosis necrosis. If it's necrosis in this area, maybe no nuclear. Yeah, we have studied the necrosis tissues, no nuclear. But in this power, you can see many particles, many black or brown particles in this bleeding area. These particles is not nuclear. What's it? It's more and more hemosiderin deposit. You know, if erythrocyte phagocytized by macrophage can form more and more hemosiderin and deposit in this bleeding area. So maybe we can find more and more brown color particles in this bleeding area. This is a hemorrhagic infarct of lungs. We have a radio here. Okay, this is a gross specimen, this area. This is a hemorrhagic infarct. It's just the color may be changed to red or black red. Sure. If just give you a gross specimen like this one, can you diagnose it's congestion or infarct? It's difficult. Yeah, it's very difficult. So, sure. We use microscopy. Okay. High power, you can say this brown color is hemosiderin deposit. And the normal structure of the lungs, just to say the alveolar walls, the type 1 or type 2 cells, and maybe small bronchs and smooth muscle cells, and some maybe the epithelium of the small bronchs disappear. No nuclear, disappear. It's just more blood red cells and some hemosiderin deposits in this area. So, give diagnosis is hemorrhagic infarct. Here is a pulmonary edema. It's very easy. We know if you diagnose a pulmonary edema, so first step is also you can recognize its lungs, and in the alveolar cavity, many fluid. Yeah, this pink area is fluid in the alveolar cavity. The capillary is also congested. Yeah, in the septal, we also can see many capillaries, but it's also congested. The character is a fluid. It's pink fluid edema. This one, this picture is a single hemorrhage. It's just a hemorrhage, no necrosis. Why? It's just a single hemorrhage in lungs, no necrosis. In low power, we also can see the erythrocyte. Yeah, many blood red cells in alveolus or maybe in the small bronchus. This is from bronchus, and maybe bleeding in the lumen. And in alveolus, many alveolus, this is blood red cells. But we use high power, we can say this is a small bronchus. Yeah, a small bronchus. The nuclear is very clear. Yeah, we can recognize the nuclear. This is the septum of alveolus have more nuclear. Yeah, the nuclear is remain. It's just a single bleeding in the alveolus. Many alveolus have blood red cells, but the constructor of the lungs we also can say remain many nuclear. So we know in these pictures, it's just a single hemorrhage, no necrosis in these lungs. Okay, you can compare. This is infarct. This is a hemorrhage. It's different. If hemorrhagic infarct in this necrosis area, no nuclear, it's just the hemosiderin, many hemosiderin deposit. But in hemorrhage, a single hemorrhage, we can see nuclear. Yeah, this is the septum, many cells, nuclear. We can see many nuclears about the septum or the bronchus, and this is just bleeding in alveolar. Sometimes also can say the hemosiderin. Can see the hemosiderin deposit, but it's different character. So, do you find it difficult to diagnose in the microscopy, especially in lungs? We studied the edema, hemorrhage, congestion, and infarct. So, if I give you a slide, the first step is also, so you must recognize its lungs. How to recognize? We must know some normal structure. So the pseudostratified columnar epithelium and the cartilage and the alveolar. Yeah, when air in alveolar is empty cavity, it's character of the lungs. And then maybe you can see some edema fluid in alveolar cavity. And sometimes maybe congestion. Yeah, the capillary enlarged and congestion. And sometimes maybe heart failure cells. Yeah, many heart failure cells. And sometimes also can say no nuclear in this area. And remain the nuclear, but bleeding in the alveolar cavity. It's a different diagnosis. Sure. Congestion, edema, hemorrhage. This morphology can in one lungs at the same time. Yeah, some patients maybe have first is congestion and then edema and bleeding. So it may be at the same time in one patient. When we diagnose this, we must to grasp the character of this patient. In autopsy about the patient of COVID-19, we also can see bleeding and some maybe edema, some patient maybe necrosis. It's different morphology about the COVID-19. It's also the virus infections can cause a very serious pneumonia and cause death, especially in the ICU. If the lungs have the bleeding or edema or necrosis, so it's dysfunction of the lungs. Okay, take a break, and then we come back to say some diagnose sections.